Session 17, Procedures and Functions in MySQL. There is a common name for these stored procedures and functions, and that is stored routines. So when we use the term stored routines, it refers to stored procedures and stored functions. Individually, we call them stored procedures and stored functions. So after completing this lesson, you should be able to define a stored routine, differentiate between stored procedures and stored functions, create and execute stored routines, manage stored routines in the database, assign variables in stored routines, handle errors in stored routines, use cursors and control flow statements, and list the limitations of stored routines. It is divided into multiple topics, heading wise. First is overview of stored routines, then creating stored routines, then variables and prepared parameters in stored routines, then managing stored routines in the database, then using control flow statements, then handling errors using cursors, and limitation of stored. First topic, what is a stored routine? A stored routine is a set of SQL statements that is stored in the server. Clients execute the stored routine by name, and instead of issuing individual statements each time. There are two types of stored routines. One is stored procedure, is a series of instructions that execute as a statement but does not return a value. It's simply taking the example of that, okay, pick up the pen and write your name. Finish. And second question, what is the sum of 5 and 9? The first question is more of instruction that you are doing something, and second question is asking something that, okay, do some calculation, return a value back to me. So returning a value is when you return to the caller. Invoke a procedure using call statement, and the procedure optionally passes back values using output variables. This is optional, passing back values. This is not return value, this is not return statement. But instead, if you look at carefully, passing output variables, that means you create variables, put the value inside it. We do not call this as a return value. This is setting some variables. And stored routines or stored functions is a series of instructions that executes as an expression and returns a single value. Call a function from inside a statement just like any other function, that is by invoking the function's name, and it returns a scalar value. Just like count, star, count is a function, average is a function, sum is a function. We use these functions in MySQL. What are the use cases of stored routines, whether functions or procedures? Stored routines are used to simplify application design. Single point of development for all data related operations. A standard language, SQL, for accessing and modifying the data. And central API for common database functions. You put them into procedures and functions. However, the biggest advantage is the security and the performance. Mostly we use stored procedure and functions for security purpose, because you don't write the code on the server side. I'm talking about the application side. Your logic is on the server. So single security model for data functionality, central processing of data securely before it is transferred. That is what the point is. You can write multiple statements and you can return one value. So the logic, business logic, or the maximum updation updation or deletion, everything is happening at the server side. You are not writing queries, you are not sending queries. So queries are written on the server side and you are just calling them by a name. That also helps you in performance, that also improves the performance. Central selection and filtering of data before it is transmitted is a good use case, good advantage of stored routines. However, there are some downsides. First is increased server load. Executing stored routine in the database might increase the server load and reduce the performance of applications because they reside on the server. When server is executing the stored routines, it is consuming more resources. Limited development tools. There are currently few development tools for developing stored routines in MySQL. True, but slowly we are picking up. Reason behind this, I must say that stored routines were not initially planned for MySQL. Until MySQL 5, MySQL 4, 4.5, there was no process, no concept of stored procedures and stored functions or stored routines in MySQL. They were introduced in MySQL 5 only. Limited debugging and profiling capabilities. This limitation can make writing and debugging stored procedures, stored routines more difficult and should be considered at the design stage. Limited language functionality and speed. Although stored routines in MySQL has unparalleled access to data, many other programming languages are faster and more general purpose with broader functionality. These are some of the issues, downsides of stored procedures. That is why they are not as popular as we have stored function and procedures in Oracle and other languages. That is true, that's a fact. But I'm sure it is picking up and it will become popular. That's the reason we are studying it, and we'll look at the advantage and other use cases also, more examples. Creating stored routines. The basic syntax to create a stored procedure is create procedure, procedure name, and the procedure statement. Like this is example of produce a single statement. Stored procedure, quite simple. MySQL create procedure, world country count. Select country count star from country. So this is a name given to your, this is a query which is given a name. So and now you can call it using this function. So create procedure, this is a procedure. Now you use call statement to call this procedure. Call world country count. Let's try this example. Select country count star from country, and now we can call it. You don't have to use parentheses to call, so this is how you get the value back. Call world country count. It is just like a prepared statement, but you are not passing any parameter. This is a group of statements given a name. The drawback with prepared statement was you could have used only a single statement. Only one single statement, no nesting, nothing could be prepared. But here you can write multiple statements, substatements, complex queries, absolutely no issues in procedures. So execute the procedure by using call statement as I have demonstrated. Similarly, stored function. Function syntax is incredibly same for stored function as well. Create function, function name, but here you must specify the type, data type of the value which the function will return. Returns followed by return type and then the function statement. This is example of a stored function that takes single parameter, perform an operation using built-in SQL function and return the results. Like create function, thank you, S as character 20. So it is taking one parameter as input which is of character type and returns character 50. Means it is return a data type character of 50 characters in length. And now what you are doing is return concat thank you and whatever you pass, because you are passing S, the past parameter is hold into S variable, and this is what we are concatenating using concat function or inbuilt SQL function concatenate. So therefore if you type select thank you and you are passing Michael as a name inside the parameter, as a parameter, you will get a return value. Thank you, Michael. So this is what you will expect. This is called return value of the function. Most stored routines in MySQL require multiple lines of code. Enclose multiple statements in stored routines by using the syntax begin and end. Within begin and block, statement must be terminated with semicolon. But here is the problem. The statement within the block, if they are terminated with semicolon, then what will happen with MySQL? MySQL will treat each of the semicolon and execute them one by one. So how can we put them together as a single group? So you need to change this delimiter from semicolon to something else. And then once your function is over, once your statement is over, you change it back. Therefore, you use a delimiter command to change the default delimiter semicolon to something else when using MySQL command line client or batch processing. For example, delimiter equal to double slash or double dollar or double piping bar or single, anything which does not have any explicit meaning for MySQL, you can use that and then change it back after writing your procedure, stored procedure or stored function. You can nest and label begin and block, that is also allowed. Now this is an example. Delimiter double slash create procedure world record count begin end, and here we are terminating it. So this is the terminator of your stored procedure, but inside the procedure you are terminating each statement by semicolon. So statement 1, statement 2, statement 3. 3 statements we are using, and you are separating them, each of them with semicolon. So select country count, count star from country, then city count, count star from city, and then country language count. You are executing 3 statements, and the name of the stored procedure is world record count, and then you can call it. Variables and parameters in stored routines. Local and user variables. There are some major differences between local and user variables. You must explicitly declare local variables, but not user variables. Local variables are local to the instance of the routine, whereas user variables are global to all statements in the session. Meaning is clear. Inside the stored routine or function, you may need some variables. Those variables are local variables, and their lifetime is the scope. The scope is the procedure and the function in which they are declared. Whereas user variables are available throughout the session, for the connection. User variables are always prefixed with @ symbol, but local variables have no special prefix. To declare local variables, we use declare statement. Use the declare statement to declare local variables and initialize user variables in stored routines, like declare tax rate, decimal, default. The default clause identifies the variable initial value. Without a default clause, the initial value of the user variable will be null. Rules for precedence for variable names. In this example, the identifiers parameter 1 and var1 are ambiguous. In such cases, the precedence rules apply. A routine parameter takes precedence over a table column. A local variable takes precedence over a routine parameter over table column. And a local variable in an inner block takes precedence over a local variable in the outer block. So look at this example. Create procedure, precedence, parameter 1, integer type we are passing, begin. Declare var1, integer default value 0. We are using another begin block. Begin, declare parameter 1, var1, character 3, default is ABC. Now this parameter 1 is passing also and we are declaring also. So which one is local? Local is parameter 1, and that is inside sub block, inner block. Select inner 1 and parameter 1 var1. So what do you do? var1 is declared outside. So inner 1, but var1 is declared inside also. Here the default value is 0, here the default value is ABC. So what you get is inside value of var1 is ABC, and that is the precedence. Parameter 1 is not declared initially null, so this parameter will have null value. And this is inner, you are just selecting inner plus parameter 1 plus var1, and then outer parameter 1 var1. So parameter 1 is whatever you are passing, and var1 is the value 0, default value 0. So this is the outer block, outer value will be printed, inner value will be printed based on the inner block or outer block where they are used. Select into. This is a very good use case of this stored procedures and function. The select into syntax stores query results into user defined variables. These user defined variables can be global, like user variables, or local, that is routine variables and parameters. User variable examples: select sum population from country into world population. Now this is a user variable. Select sum population into world population from country can be used without prior declaration. Local variable example: select count star from city into total cities. This is local. Local means within the procedure you are writing it. Select count star into total cities from city. But then in local variables you know that one rule, that they must be declared before you use them. But user variable you need not declare them, as we have studied in prepared statement previous lecture, that you can simply start using. If they are not declared, they will be taken, default value will be null, and you don't need to declare them in advance. The set statement allows you to assign a value to a user defined variable using equal sign or colon equal sign as an assignment operator. For example, delimiter is this: double slash, create function, final bill, total charge, decimal data type, tax rate, decimal, return decimal. Now this is the body. Declare bill decimal point, set bill equal to total charge plus total charge plus tax rate, and return bill. So we can use set statement as we used it right in the beginning when we discussed the prepared statement and user variables, and we can use set also here. You can assign values to multiple user variables in the same set statement by separating each variable assignment by a comma, and that's the same syntax we discussed in variables examples in the previous lecture. Parameter declaration. Stored routines include parameter declarations that allows you to pass values to the routines. Stored routines accept three types of values: in, which is going in. Take it like this: inside the routine we are sending some value in. So this is a value which is initialized outside and used inside. So inside it will be read only, and then out. So out will be used outside, initialized inside, and used outside. And in out, which can be used for both sides. In indicates an input parameter that is passed in the form of passed in from the caller to the procedure. Out indicates an output parameter that has a value set by the procedure and is available to the process calling it after the procedure terminates. In out indicate a parameter that act as both in and out parameter. Stored functions regard all parameters as in only. That is applicable in, out and in out, applicable only for stored procedure. Stored functions treat all of them as in parameter only. Do not use in, out or in out with stored functions, because function by definition has a concept of return. We have a return statement in function. So therefore functions are more explicit when it comes to what is going in, what is coming out. So parameters, all the parameters are treated as in functions, and return statement is explicitly set in functions. So therefore do not use in, out or in out in stored functions. These are for stored procedures. In parameter example, create procedure name, and you specify within the parentheses. When you specify parameter, you specify this value in parameter name, data type, procedure statement after that. This is default parameter type if none is provided. That means even if you don't specify the keyword in, it will be taken as in parameter only. Any change to the in parameter value are not visible to the calling program because they are read only. They are inside the program. You cannot change them. Out parameter, create procedure name, out, parameter name, data type. The initial value is null, return value is visible to the caller, and this can be changed within the body of the procedure. Similarly, in out, you can change the body, change the variable inside the procedure. Whatever value was there, whatever was passed, it will be visible to the calling program after you return back. That was many variables and parameters in stored routines. Next topic is managing stored routines in a database. Stored routines in databases. Each stored routine belongs to a particular database. They are not global. This has several implications. When you invoke a routine, it performs an implicit use statement that is undone when the routine terminates. You cannot have use statement within the stored routine. Qualify routine names with a database name to refer to a routine that is not in the current database. Quite simple. If you are working in Word database and you want to store routine, you want to execute a stored routine, call a stored routine or function or procedure from the Sakila database, you must pass it, qualify it with Sakila.procedure name. For example, to invoke a stored procedure P in the database test, you use test.p. To select a value of a function f in test database, you use select test.f. When you drop a database, you implicitly drop all the stored routines associated with the database. You can examine stored routine in three ways. Show create procedure will show you the complete statement, declaration, and show create function return the string used to create or recreate the named routine. Show procedure status and show function status return the characteristics of the routine, such as the database name, type, creator, creation, and modification dates. The information schema dot routines table means the routines table inside the information schema provide information about the stored routines, both procedures and functions, and return the majority of the details in both show create and show status statements, including the syntax used to create the stored routines. Removing stored routines. To delete an existing stored procedure, we can use drop procedure name. Similarly for function, drop function name. If you are unsure if the stored routine exists, you can use if exists clause before the procedure or function name. For example, drop procedure if exists procedure 1, or drop function if exists function 1. That was a brief discussion about creating variables, parameters, managing, but the main business logic or the programming concept comes when you use control flow statements. That means when you use if statement, when you use loops. Without that, there is no point thinking of the word program. Programming itself refers to these things. So therefore, if you want to make best of stored functions and procedure, you must learn the control flow statements and constructs, which helps you taking decision and repeating multiple statements, that is iteration. Control flow statement control the order in which operations are executed in your code. The two types of control flow statements are conditionals and loops. Conditionals are the statements that are executed under certain conditions. In MySQL, these are represented with if and case. Loops are the statements that are executed repeatedly. In MySQL, these are represented with repeat, while and loop statements. We need to understand each one of them. If statement. This is the most basic conditional construct. Every programming language have it. We start programming with one simple line saying that any programming language have three main construct which makes the program, the word program. One is sequence, second is selection, third is iteration. Sequence means writing statements one by one, no transfer of control, executing the statement as if you are reading the book line by line. Second is conditional, where you encounter a condition and you transfer the control as you visit a website. When you visit a website, you keep traversing from one page to another based on your conditional flow. Let's go to this page, go to that page. You don't read the entire website in one flow, in consecutive sequential manner. Similarly, iteration is the repetition of statements. Any code block which is being repeated, that is called a loop or iteration. In most basic statement is if statement, here terminated by and followed by if. Can include optional statement block, else if and else statements. So if condition, then do these statements, else if this another condition, then do this, else do this, and if. Case statement. Instead of using multiple if, it is better to use case. Case is nothing but a replacement for multiple if statements. A simple case use case statement to compare a known value with another value. Like case value, when this, then do these statements. When this value, then do these statements. Else do these statements. It is as I said, you can compare it with multiple if statement. This increase the readability. This is more cleaner code compared to multiple if statements. Case value is compared for equality with a set of other values. If no when value matched are provided, then the else block will be executed. Then we have another statement, searched case. The searched case uses case statement to execute code based on conditions. Case, when test condition, then execute. When this condition 2, then do this, else do this. Same process, execute first block of code for which the condition returns true, and execute its else block if condition returns false. Repeat statement. Repeat a block of statement until the test condition becomes true. It is a loop. Always execute at least once. Repeat these statements until this condition is true. For example, when the first execution itself the condition is true, then it will stop. So at least the condition is executed once. Can optionally include a label. My label, repeat, and then until this condition becomes true, repeat and repeat my label. That makes the readability, that increase the readability of the repeat statement actually. While is a loop, iteration, while conditions true. Do this. Now what is the difference between repeat and while? While loop may not be executed even once, because while this condition is true, if the condition is false, it will not be executed even once. So while this condition is true, do this and while. It contains a block of code that repeat as long as the test condition is true, which means if the condition is false, it will not be executed even once. And this is the primary difference between while and repeat. It does not execute the code block if the test condition returns false. This also supports labels the way repeat supports. The loop statement, loop, and then no condition, you have to specify everything inside the body. You have to use some statement, the leave statement somewhere with some conditional or based on your logic that you want to exit from the loop. Otherwise the loop will become infinite, means it will never be terminated. So this does not require a test condition. Hence it's the responsibility of the developer to write the test condition within the loop. Repeat a statement block consisting of one or more statements until it encounters a leave statement. Means leave statement cannot be without any conditional. Generally you put some conditional example in condition inside the loop to exit out of the loop, and that will be leave. This also supports labels. Leave and iterate, corresponding to break and continue in other languages. C language have break and continue, C++ have break and continue, shell programming have break and continue, Python has break and continue. But here we have leave and iterate. The meaning is same. Leave stands for break and iterate stands for continue in other languages. There is a common programming, only the names are different. MySQL provides two control flow statements that operate within loops and support labels. One is leave. This statement exits any labeled control flow construct such as loop, iterate or while. Leave can also be used in labels begin and block. Iterate will basically put the execution control right in the beginning of the body where the loop starts from. So like this is the code block. Here you write leave statement, iterate. So the moment you write iterate, the rest of the part will be ignored and the control will be checked in the initial condition of your loop or initial condition of your iteration block. So possibly deciding that whether I should continue executing the body or I should stop. So condition will be evaluated again, that is the iterate. Otherwise it will continue executing. This statement returns control to the beginning of the loop construct as if restarting it. If you provide a label to the iterate statement, it returns control to the beginning of that labeled loop. Handling errors. Declaring error handlers. You can create, now what is this error handler? You may say that MySQL also have error handlers and they display appropriate message. Fine. But a non-developer or non-DBA person will not understand those error messages. What we do in error handling is we handle exceptional situations where MySQL is not able to comply with the statement, not able to execute the statement, and we want to display a meaningful message, a graceful message to the user. That we do through exception handling or error handling. So you can create a handler for error conditions. The handler declares a statement that executes when a specified error condition happens. You create handler with begin end block. Handler takes one of the two actions after executing. One is continue, second is exit. Continue means execution of the current block continues. Exit means execution terminates for the handler's block. The handler catches errors of the specified type and executes the provided statement. This is how we declare it. Declare continue handler for 1051. So we are declaring a handler for 1051 error message. Insert into log table message value no such table. This is similar to catch block in Java or PHP as I said. Every programming language have this error handling try catch, try except in Python. The declare condition 4, that is named condition. You can declare a named condition also. Declare condition 4 syntax allows you to give a symbolic name to a MySQL SQL state error handlers, error numbers, like declare null not allowed condition for SQL state code 23000. Use symbolic names to create handlers now. Handlers that use symbolic name must be in the same block as the statement declaring the name. For example, declare no such table condition for 1051. Declare continue handler for no such table. You are using your own user friendly name which you have declared. You have given your own name to it for the error code 1051. Insert into table name and then more statements, whatever you are writing, but this error handler will be used. Statements outside begin end block cannot use these symbolic names. They are available within the block only. Resignal. When an error is processed by a handler, that error is not visible to other part of MySQL. The error or warning is not seen by code outside the block containing the handler. To raise the error outside the current block, we use resignal. Resignal is used within a handler to pass the error block outside the current block. Without any parameter, it passes the MySQL error, SQL state and message text as received. With parameters, resignal can change any part of the error information. Signal. You can raise an error to the environment by using signal, like signal SQL state 45000. Set MySQL error number 1000. Message text is error occurred. This is what the meaningful message you give to the user for the SQL state 45000. This statement behave as if you have executed a query that raised an error with the MySQL error number SQL state and error text as shown here. Use signal and resignal when working with nested code. For example, in an update transaction that calls a function, the function can use signal to raise an error to the update, rolling back the transaction. Signal can be used to pass error back to the error handling code in your application via connectors. Next topic is cursors. Cursors are control structures. Simplest possible definition of cursor will be result set with a name. Think of them as a result set of a query with a name. When you open it, the result set is available. And it is available like a stack. You execute all the rows of the result set one by one or process them, do something, and when it is empty, you close it. So cursors are control structure within stored routines that retrieve results one row at a time. That is the reason I have given it a name result set. That's a better understanding. Records one row at a time, because once the result set is available, you process them one by one. Use cursors in loops. That says it all actually. Same thing. Result set executing one by one means loop that fetch and process one row with each iteration of the loop. How do we declare them? We declare cursor using the syntax declare cursor name, cursor for and the statement. Variable and condition must be declared before declaring cursors. When you declare a cursor within a compound statement, the cursor scope is limited to the compound statement. If you declare multiple cursors in a single block, each cursor in the block must have a unique name. Working with cursors, as I said, first you need to open the cursor. You can open, fetch row from and close cursors. Open a previously declared cursor means get the result set, give it a name. Let me start fetching the row one by one. That is open cursor name. Fetch. Read the next row of one or more columns from the cursor, from the open cursor. Assign each cursor column to its own variable and advances the cursor pointer. You cannot go back in the cursor, let me tell you. So fetch cursor name into your own defined variables so that you can process these variables one by one. And then close this. Close cursor name. MySQL gives an error if you fetch past the end of the cursor. MySQL closes all cursors that have not been explicitly closed at the end of the compound statement block that declares the cursor. This is a very good example of cursor. Create procedure, population, populous countries, begin, declare done, integer default false, declare time, population, t name, t population, declare cursor for select name population from world.country, declare continue handler for not found, set done equal to true, open the cursor, read loop. So this is your loop statement. Fetch cursor into t name, t population, temporary name, temporary population, or whatever name you want to give it. If done, then leave read loop, and if population greater than 1 million or 1 billion, whatever, insert into world big population values these two values, and if and loop, close the cursor. So the point is, we are fetching the value, we are doing some calculation, processing, business logic, applying it, putting in another table based on our requirement, and then closing the cursor, moving on to the next statement. This is a very good example of cursor. Limitations. Cursors are read only. They cannot be used to update rows. MySQL does not implement the syntax update where current off or delete where current off, because updatable cursors are not supported in the server. Cursors are sensitive. The server may or may not make a copy of its result table. Cursors are non-scrollable. I told you that you cannot go back. You cannot scroll up or down in the cursor. You must fetch each row in turn from beginning to the end without skipping any row or without going back. Limitations of stored routines. The following statements are not permitted in all stored routines, procedures and functions. Any statement not permitted in the prepared statement except signal, resignal, get, diagnostic. Alter view not allowed. Load a data, load a table not allowed. Other limitations include a prepared statement executed by a stored routine cannot refer to local variables in that stored routine. To explicitly start a new transaction in a stored routine, you must use start transaction. In addition to limitations of stored routines, generally the following limitations apply to stored functions. The following statements are not allowed in stored functions. Statements that cause an implicit or explicit rollback are not allowed in functions. Statements that return result set are not allowed. Only single scalar value is allowed. Process the result with a function by using select into var name or a cursor and fetch statement instead if you want to. Handler read are not allowed in functions. A stored function cannot modify a table that is being used by a statement that invoked it. You cannot use multiple aliases to refer to a temporary table, and you cannot use stored functions recursively. Recursive functions are not supported the way they are supported in other RDBMSs and other languages. These are limitations of stored functions. And that's all for the session 17. Thank you very much for showing the patience of listening.